Rotational rate can be defined as how fast a fluid parcel rotates about its own axis. To understand this definition, consider the following illustration. This is a fluid flow in a two-dimensional view. Let's say, there is a rectangular fluid parcel. This fluid parcel is a sample of a collection of fluid particles. In a flow, in addition to moving translationally, the fluid parcel also moves rotationally, or rotates about its axis. Now, how fast the fluid parcel rotates is the rotation rate. The fluid parcel rotates because there is a shear stress force acting on the surface of the fluid parcel. In other words, when the fluid parcel has a shear strain, then the fluid parcel will rotate. Shear strain in fluids applies to viscous fluids. In other words, the rotation rate of a fluid parcel can be an indicator of the viscosity of the fluid. In a non-viscous fluid, the fluid parcel only moves translationally. While in a viscous fluid, the fluid parcel moves in addition to translational motion and rotational motion. Assume that the velocity field of the fluid flow is a vector v equal to ui hat, plus v j hat, plus w k hat. And, the fluid parcel is in the xy plane. Then the axis of rotation of the fluid parcel is the z-axis. Its angular velocity is omega z equal to half of partial v partial x minus partial u partial y k hat. If the fluid parcel is in the xz plane, omega y is equal to half of partial u partial z minus partial w partial x j hat. If the fluid parcel is in the yz plane, omega x is equal to half of partial w partial y minus partial v partial zi hat. If a fluid parcel rotates in three-dimensional space, its angular velocity is the sum of omega x, omega y, and omega z. Well, this form is the curl of the velocity field vector. Often written as nabla, cross, vector v, hopefully useful. And, don't forget to watch the next video.
To be educated, but I'm so frustrated. Hello to my loneliness. I guess that ignorance is